In this video we are going to talk about infinite series. Notice the difference between a series and a sequence. A sequence is just a list of numbers. A series is a sum. The sum of the first two terms, we will call it S sub 2. The sum of the first three terms, we are going to call it S sub 3. The sum of the first n terms, we are going to call it S sub n. If we only have the first term, we will call that S sub 1. All of these sums are called partial sums. And the sequence of all those partial sums that we represent like this is just a sequence of partial sums. And that particular partial sum is called the nth partial sum. Now, if the sequence of all those partial sums is convergent and the limit of that sequence is S, then we say that the series, the sum of the a sub n for n equals 1 to infinity, converges. And we write that the sum is S. There are some series that we must know because we will use them to find out about the convergence of other series. The geometric series is one of them. A geometric series is a series of this form: a plus a times r plus a times r squared, etc., etc. Notice that if I divide any term by the previous one, I'm going to get r. If I divide this by this, I get r. If I divide this by this, I get r. So r is called the common ratio. Now, the sum of the first n terms of a geometric series is given by this formula, which we can write like this also. I'm not going to derive this formula. And we just said that if the limit of the partial sums exists as a real number, then that will be the sum of the infinite series. So the limit of the partial sum is the limit of this. Now, if the absolute value of r is less than 1, then this term will approach 0. Why? Well, let's say that r is 0.5. When you raise 0.5 to the square, it becomes 0.25. And when you raise it to the cube, it becomes even smaller. And to the fourth, it becomes even smaller and smaller. So r to the n plus 1 becomes 0. And if this becomes 0, then the limit of S of the partial sums when n approaches infinity is a over 1 minus r. Because all of this becomes just 1. This is 0. And that means that the series converges to that number. But if the absolute value of r is greater than or equal than 1, the series diverges. Why? Well, let's see. If r is equal to 1, the series becomes a plus a plus a because r is 1. So we have a plus a plus a. Okay? And the nth partial sum, which is a plus a times r plus a times r squared up to a times r to the n, is now a plus a plus a plus a, n plus 1 times. In other words, n plus 1 times a. And therefore, the limit of S sub n will be plus or minus infinity depending on the sign of a. Therefore, the series diverges. Now, what happens if r is equal to -1? In that case, the series becomes, notice if r is -1, then we're going to have a, -a, then we're going to have a again because -1 squared is 1, and then -a, and so on. And therefore, the sequence of partial sums is going to be a, and the second partial sum is going to be 0, and the third partial sum is going to be a, etc., etc. So the sequence of partial sums becomes a, 0, a, 0, 0, etc., etc. So it keeps going up and down from a to 0, a to 0, a to 0. Therefore, it diverges. Finally, if the absolute value of r is greater than 1, that means that either r is greater than 1 or r is less than -1. Now, if r is greater than 1, then the limit of this number greater than 1 raised to the n plus 1 when n approaches infinity will be plus infinity. And therefore, the limit of s sub n, which we said that was this, if this is approaching plus infinity, all of this is going to be negative infinity. This is going to be a negative number also, so this is going to be infinity. Okay, the limit of the partial sum will be infinity, and therefore the series diverges. Now, what if r is less than -1? In that case, this oscillates between positive and negative values that grow in magnitude. Therefore, the limit of the partial sum will be growing in magnitude but going up and down, and therefore the series diverges. So what you should remember definitely is that if the absolute value of r is less than 1, the geometric series converges. If the absolute value of r is greater than or equal than 1, the series diverges. This exercise that we did here, analyzing all those cases, it's very educational, and you will use reasonings like that in the future to determine the convergence of other series.